Okay, so last time we did like scalar vectors, and this time we will just move ahead with this. Do one question that basically usually comes a lot. So let's suppose you have one vector like this. It's called x, and they have given you another vector like this. That's y. Now they say that if this x is equal to y minus z, okay, they say draw a vector that represents z. So whenever such question comes, the first thing you should always do is that you make z the subject of the equation. So if I take z on that side, x will come on this side, so it will be y minus x. Now, currently we have x and y, so this means they're positive. Their directions are like, we can take it like this. This means that we have positive y and minus x, so we can redraw these vectors. So minus x will be exactly opposite of what x is. And because we have positive y, that would stay the same. Just like that. Okay. Then what you're going to do is you do head to tail. So you make one vector, minus x, and then you make the other vector connected to the head of the previous one, y. This means that the z, which is the resultant of these two, will be from here till here, and that would be z. Is it clear?
Yes, sir.
Right. Now, sorry? We did analytical method as well. Yeah, okay, we did. Now today we are moving towards a very, very important a topic that's called resolution, right? Now, resolution of vectors is a method that's analytical only, like I told you. So you need to understand that vectors can be either horizontal, they can be vertical, or they're at some angle, right? Vectors at an angle. Now, horizontal means that basically a vector can be right, could be left. Vertical means a vector could be up or down. And vectors at an angle means that they are like maybe like this, or this, or this, or this. Now, the horizontal vectors, horizontal and vertical, basically are easy because they're already, we have a name to them. But the vectors at an angle, we need to resolve them. So first of all, we should learn about some of the math rules here. First rule is that cos theta is basically adjacent over hypotenuse. You might know this already. Similarly, sine theta is opposite over hypotenuse, and tan theta is basically opposite over adjacent. Now, with that said, we should understand, let's suppose in one example, they have given a vector like this, and the angle is theta, and the value of vector is f. Okay. Now, so what I'm going to tell you now, please do make sure that you basically understand. And if you don't, please ask me again. So, one second. Okay. So any vector can be broken into its horizontal and vertical components. What I mean by this is, in order to go in the direction that is shown, one component should be towards the right, and one component of this vector should be towards upwards, like this, right? This means this is the horizontal component and this is the vertical component, right? Now, if you look closely in the diagram, you would realize that the angle, this angle, basically touches two vectors. One, the original one, that's the resultant, and one, which is basically a component. If an angle is next to a component, that makes that component the adjacent one, and the vector that is not connected, or the angle is not next to it, that becomes the opposite one. Is it clear?
Yes, sir.
Now, this means that when you have to find what is adjacent, right? Because you know f. So we could use, because cos theta is this, so we could write that the adjacent is basically equal to the hypotenuse times cos theta. And for sine, the opposite will be hypotenuse times the cos theta. So for this one, the hypotenuse is f. So we're going to write f cos theta. And for the opposite one, we're going to write f sine theta. Is it clear?
Yes, sir.
Now, similarly, the same diagram can also be given. Like f is still the force, but this time the angle is given here. What happened to the angle here? This means that when you draw the components, one will be towards the right because you can see resultant should be in the middle, right? And one upwards like this. So this would mean that this is the horizontal one, this is the vertical one. Now, you can notice this time the angle basically is next to this vector, so that makes it the adjacent one. And this one, the angle is not next to, that makes it the opposite one. Now the whole thing changes due to the placement of the angle, right? This means that this will be f sine theta now, and this will be f cos theta. So what I'm saying is that you need to look at basically the angle. The vector component, which is next to the angle, is always cos theta, and the opposite one is the sine theta. Everybody understand this? Okay, cool. Pretty good. Now things from here basically becomes easy because we're going to do this exercise by exercise. So in the first exercise, we're going to learn how to make components. Right? So the first question, it's like this. It's 35 meters per second. And the angle is given as 57 degrees. And another question, the vector is like this. The angle is given from here. Tell you the values. So this is basically 34. And from the value of this component, this vector is 12 meters per second. Now, the third one is like this. The value is 20 meters per second, and the angle is given from here, which is 30 degrees. So I'm going to solve one of these, and the rest of you should solve, right? So the first, I'll solve two because one I just told you. So 2 means that the vector here, if in order to go like downwards like this, one vector component should be left and one component should be down. So once I made the components, then I'm going to look at the angle because the angle is next here. This means that this will be the horizontal and vertical. So the horizontal component will be 12 times cos of 34. How do I know? Because the angle is next to that. And then for the vertical, it will be 12 sine of 34 because the angle is not next to it. So when I solve this, this should come out as 10 and this should come out as 7. Now, I want you people to do 1 and 2. Then I'm going to ask you. Okay? Go on.
Sir, what are we doing?
Resolution. Why are you late, by the way?
I just came home.
Okay. This is resolution. We are making components. So you break the components like I showed you on top. First draw them and then give me the value.
Is this vectors?
Yes. Have you not taken the class before? I mean,
No.
this is your first class.
It's my first class in vectors.
Were you absent before?
Do we have class Monday, Tuesday, and Wednesday?
Yes.
Yeah, so once I joined and you were taking an A2 class, so I left. It was gravity.
Day, on the same day, then we had it at 8 p.m.
Oh, okay.
No worries. The recording is already there in the group. Okay, you can catch up. But this is completely something new in vectors. So it has nothing to do with the previous vectors. Okay.
Okay.
You watch the recording after this class. If you don't understand something, you do ask me. Okay.
Okay, thank you.
Yeah. Okay, everybody's done? No?
Sir, I'm almost done.
Okay. Right. So who missed the first 5 minutes of the lecture today? Ramin and nobody else? Everybody else here? Okay. Ramin, I'll give you a summary. Okay.
Okay, thank you.
Okay. Now, so basically, Ramin, we started from here. We should understand that vectors can be of 3 types, okay? They can be horizontal, which means right or left, vertical, which means up and down, and vectors at an angle means that they are at some angle, as you can see, right? Now, to add or subtract right or left, you've already done it in IGCSE, so you know it's very easy. You subtract them, you add them. But vectors at an angle, you need to use cos theta, sin theta, and tan theta formulas. Okay, is it clear?
Yes.
If you have a vector like this, f and theta, so basically the 2 components would be like if you go like in this direction, which is like northeast. So one vector should be towards the right, and the other component should be towards upwards, right? So we're breaking f into 2 of its original components. Do you understand?
Yes.
If you look at the angle basically touches 2 vectors, the original one and one of the components. Currently, it's horizontal. So whichever component it touches, that is the adjacent one. And the one it doesn't touch, that is the opposite one. Is it clear?
Yes.
So the formula for adjacent is that if you multiply hypotenuse with cos theta, you get adjacent, right? This is why the hypotenuse was f. So we multiplied f with cos theta to find the horizontal component's magnitude. Similarly, for opposite, I wrote it wrong here. Sorry, it should be sine theta. Okay, so we wrote hypotenuse times sine theta to find opposite. Is it clear?
Yes.
If you look at this drawing, you will see that now the angle is touching the vertical one. It's next to that. So this makes vertical the adjacent and horizontal as the opposite. So now it will be f cos theta for vertical and f sine theta for horizontal. Is it clear?
Yes.
Now in these questions, what I did was, I was given 12 and 34 from the horizontal. So I made 2 components. So to go in southwest, one vector should be towards the west and one should be towards the south or left or down. Is it clear?
Yes.
Then, because the angle was next to the horizontal, so horizontal would be 12 cos of 34, that's 10. And vertical would be 12 sine of 34, that's 7, right? And then I asked them to do the other two. Is it clear?
Yes, thank you.
Okay. So anyone got the answers for both?
Yes, sir.
Okay, first one. Just need to tell
Yes,
me
sir. So
horizontal.
for the first one, the vertical is 29.4 meters per second and the horizontal is 19.1 meters per second.
Okay, that's good. And what about the third one?
The third one is 10, the horizontal is 10 meters and the vertical is 17.3.
That's correct. Okay, so basically now you guys check your drawing, right? To go in this direction, one vector should be towards the right and the other vector should be upwards like this, right? Now, because next angle is right here to the horizontal, so this means that the horizontal would be 35 cos of 57 degrees. That makes it 19.1 meters per second. For vertical one, which is not next to the angle, this means 35 sine of 57, which is 29.4 meters per second. Everybody understand this? Those who got it wrong?
Yes.
Now the next one, if you look at this is like southeast, which means one vector down. Okay, this wasn't like too precise. Okay, it won't let me do it. Why? And this is like this way. Okay. Now because the angle is like next to this means that this is vertical, this is horizontal. So horizontal we could write as 20 sine of 30. Why sine? Because angle is not next to it, which makes it 10. And vertical is 20 cos of 30, which makes it 17.3 meters per second. It is as simple as this. Is it clear, everybody?
Yes, sir.
Yes.
So basically, you just learned today that how to break a vector at an angle into its original components, its origin, right? Now, what if its components are given and you need to find the original, the resultant vector? So what do we do? Now let's look at that. And that's extremely simple. So suppose in the first part, they have given two vectors like, oh, this is not a vector. Arrow. Okay. One like this and one like this. Its value is 5.7 and here it is 3.4. Then in the next one, they have, wait a second. They have given one vector like this and the other vector like this. Its value is 10, its value is 3. And the third one is given like this and this. So this is 12, this is 20. And they say find resultant vector and angle from the horizontal only. Okay, now we're going to look at it. So I'm going to do the first one, okay? And then you can see those steps and you can, do it on your own. It's pretty simple. So basically, if something is going right and upwards, it means the resultant has to be somewhere in the middle as well. This means now we also need to find this angle theta. Let's call this f. Okay. So to find f, what you do, you use Pythagoras theorem, which is 3.4 squared plus 5.7 squared, just like we have done it before as well. Also in O levels you have done. So once you do that, this will come out to be 6.64. Now, what about the angle? Now, you need to understand if the angle is next to this is the adjacent, this is the opposite. And now you can use tan theta, because tan theta is basically opposite of adjacent, which means 3.4 divided by 5.7, like that. So tan of inverse of 3.4 over 5.7 should give you about, I guess, 30.8 degrees. Do you guys understand? That's pretty simple. So can you also do it for the next two?
Yes, sir.
Okay. So my subscription to Zoom has finished. Got to renew it. So unfortunately, the class will end in 10 minutes. But you guys got to rejoin, okay? Because we're not finished yet. But in fact, we do this and then we're going to finish and continue it in the next class, basically. So all the lectures are posted after the class. You can always review them. And it's a good habit that if you have confusion in something, you can always review it before the class so that you can ask. Okay. That's the point of putting all those lectures. All right, you guys done?
Yes, sir.
Okay. Can you give me some answers, please?
Sir, for The second question, the resultant is 10.4 and the angle is 16.7.
Okay, that's correct. And for the
And for the
next one,
third one, the resultant is 23.3 and the angle is 59.
59. Okay, yes, that's correct. Okay. Now what you do is, you know that the resultant here will be like this in the center somewhere, and you need to find this angle, theta. So you use f equals to 10 square plus 3 square under root. That would give us, was it 10.4, right? And the theta should be tan of inverse of basically 3 over 10. So that should give you 16.7 degrees. For the last one, it would be like this somewhere. And you need to find this angle theta. So f, this vector f, will be equal to 20 square plus 12 square under root, which basically should be 23.3. And the theta will be tan of inverse 20 over 12. That should be about 59 degrees. Who did not understand this, please let me know.
Sir, I don't get the part where Pythagoras theorem. Why aren't you doing f square? Because it's a square is equals to b square plus c square.
Yes, but when you take under root, f, the square on f
Oh,
goes
yeah.
away.
Okay.
So I basically skipped this step. Okay.
Okay, got it.
Yeah. Okay. Any other questions you guys have?
No, sir.
Pretty good. Now today, what we learned in resolution, it's pretty, simple mathematics. We learned how to break a vector into components, and we also learned if there are components, how do we form the vector. In tomorrow's class, we're going to learn that if there are multiple vectors at one point, then how do we resolve them? So just go through this whole thing and just let me know. Okay. All right then. Bye. See you.